Hi, everybody. Welcome to your weekly space hangout for Thursday, October 25th, 2012. This week, we got a pile of stories for you. We're going to be talking about how I've lost my notes. They're there. Okay. We're going to be talking about the discovery of a planet around Alpha Centauri, a flash coming out of the Milky Way supermassive black hole, a huge, very long afterburner coming out of a galaxy. It's a very black hole show, actually. A small supermassive black hole. The possibility that an exploded rocket is going to make space completely inaccessible, surrounding the planet with a shrieking sphere of shredded metal. And whether or not you can actually scream in space. And if we have time, we'll talk about the recent Soyuz docking. So joining me this week, yay, we've got the band back together. We've got Amy Shira Teitel from Vintage Space. We've got Nancy Atkinson from Universe Today. We've got Nicole Gugliucci from Cosmo Quest. And we've got Jason Major, should pay attention to the show that he's on, from Lights in the Dark.
Always paying attention, Fraser.
Cool. Well, let's get started. Let's get started with the big story that we should have covered last week, and so I apologize. You've probably heard this about 800,000 times already, and that is the discovery of a planet, an Earth-sized planet orbiting Alpha Centauri. But it comes with a bit of a catch. So, Jason, you wrote on this. So, what's the story?
I did. I mean, this is big news. This is huge news. This is galactic-sized news. I mean, this is the closest that we've come yet to really kind of like the holy grail of exoplanet discoveries. What researchers with the European Southern Observatory have identified is an Earth-sized terrestrial planet orbiting a star within the nearest star system to Earth, the Alpha Centauri system. Actually, the planet orbits the second star in the system, which is Alpha Centauri b, and it's Earth-sized, but it's a little too close to the star to actually be Earth-like. So it's not really in that Goldilocks zone, habitable zone around the planet where water could be liquid on the surface. It's really hot. It's only about 3.7 million miles away from the star. So that's even closer than the planet Mercury. That's actually almost 10 times closer than the planet Mercury. So it's a hot little place. But the exciting thing is that they're actually able to spot something that small. Now, granted, it is the closest exoplanet yet discovered. It's the lightest exoplanet yet discovered, but it's still not that Earth-like world they're looking for. But regardless, it's pretty much the exciting news in exoplanet discovery of probably the entire search for exoplanets.
So, what was the technique that they used to find it?
Well, they used the HARPS observatory, the observatory was the Lucilla Observatory, and the method is HARPS. Now that stands for, hold on a second, High Accuracy Radial Velocity Planet Searcher. And what they do is they can spot a star, watch a star. Obviously, Alpha Centauri is easy to spot. They watch a star and they see if it wobbles. And the wobble is caused by the gravitational tug of a planet in orbit around it. So after watching Alpha Centauri b for, I think it's about 4 years, they were able to confidently say, yes, there is a planet of X mass. I think it's 1.13 Earth masses orbiting that star. So I mean, this isn't, we think it is, it's there.
Now, sorry, is anybody else getting a weird stutter from Jason, or is it just, am I the only one seeing that? Nobody else is seeing it? Okay, good. Well, then I'm hoping that nobody else watching this is seeing that either.
I just made that one for you.
No, there's something really, it's almost like Max Headroom. It's quite a weird thing.
Oh, yeah, of course.
Right. Okay. So the radial velocity method, right? As you mentioned, this is the way you measure the star moving back and forth, and that's different from the.
It's different from what Kepler does, because Kepler watches the transit. Looks for that little bit of a dimming. Whereas this actually, it doesn't matter if the exoplanet is crossing in front of the star from our point of view, because that's what the limitations of Kepler. Even if it's not crossing the star, it can still pick up that little wobble, that little tug, where it goes back and forth.
And the orbit, as you mentioned, is really tight. I mean, it is not a place that humans would live.
It is. I mean, like I said, it's almost 10 times closer in to Alpha Centauri B, which is a sun-like star. So you can picture a planet orbiting the sun 10 times in closer than Mercury is. So you're going to end up with a pretty hot little world.
Yeah.
But there is a terrestrial planet, so that's exciting. The fact that it's Earth-sized, that's exciting. But it's still really far away. I mean, if you really think about the scale distance of the Alpha Centauri system, even though it's the closest star system to our solar system, if you took the distance from Earth to the Sun and shrunk that down to be about an inch, okay, so you take that 93 million miles, you bring it down to an inch scale, the Alpha Centauri system would still be 4.5 miles away. So there's a big distance to go there. It's not like we can just send a spacecraft over, check it out, see what's going on over at Alpha Centauri.
Yeah. So I guess the big question then for a lot of people is going to be, are there other planets at Alpha Centauri? Is there any way to know? Are there Earth-sized worlds there? That are maybe in that Goldilocks zone?
That is the question, and that's what they're going to be looking for and seeing if they can pick up the tug, the little gravitational wobble from either Alpha Centauri B, A, or who knows, maybe even Proxima Centauri, the little dim red star that is technically the closest star to our own.
Yeah, I mean, the big thing with this is that finding these planets, it really depends on, or these planets that are orbiting really close to their parent stars are a lot easier to find, both because they are yanking these stars back and forth, the gravitational interaction is very high, but also the length of time that this is happening, it's happening every 3 days. Mm-hmm. So they've got, they can see they can tease out these really subtle differences in the position of the velocity of the star, and they can then work out that a planet exists. Once you get to things that maybe take a year to move around, that gets a lot more difficult to tease out, and you got to, essentially spend 100 years watching this star to make the same to catch the same kind of gravitational interactions. But still,
what happens if you've got a planet like Saturn, orbiting a star like the Sun? You're still looking at nearly 30 years to make one full orbit. Well, that's really difficult to observe and to measure.
Yeah.
So that wobble, that tug isn't going to be very obvious. But this exoplanet goes around every 3.2 days, so it's always giving a little nudge to that star.
And there's a great go ahead, Nancy.
Well, there's been a lot of discussion whether this discovery will spur some sort of renaissance or resurgence of space exploration. But I think the thing that people have to remember is even if we were able to take our fastest spacecraft, which I think was Helios, or there was also New Horizons was pretty fast. I know Helios is traveling like 240,000 kilometers per hour, and even at that speed, if we could get a spacecraft to go that fast, it would take almost 20,000 years to get there. So we're in no way able to do anything quickly here as far as sending a probe there.
Yeah, I mean, think about Voyager 1. We launched it in 1977. It went through the entire solar system. Now it's just now maybe breaking through the edges of our solar system, and even that would take 40,000 years to get to Alpha Centauri. So that's...
Yeah.
That's a long trip.
And there's a great sort of trope in science fiction, this concept of, you send a spacecraft and then the technology improves so much within the next 100 years that it overtakes the first spacecraft, picks up the passengers and takes them along, and then, 100 years later, an even better spacecraft comes along and picks up the passengers of both So, with these kinds of enormous distances, until you can really get to significant fractions of the speed of light, attempting to move to these other worlds is very difficult. I mean, it would take there was a great book by Paul, is it Glister? The guy who does Centauri Dreams, and he did a great book about sort of like what would it actually take to send a probe to another world. Even just a tiny little probe, it would take the entire gross domestic product of the entire planet for 10 years or something to actually just send a tiny probe to the nearest star within a feasible amount of time, and not even have humans on board, just a robot. So we're a long way away from that. But there's some great technology. I mean, NASA is actually working on a warp drive, and NASA is, so there's some actual really interesting technologies that might come out shortly. So anyway, huge story. Probably
maybe we can Z-pinch our way. Maybe we can Z-pinch our way over to Alpha Centauri and check it out. And
yeah, and so I'm gonna put this on the top 10 list, top 5 list of the top stories of the year. It's a phenomenal discovery, and I think we're gonna be both sort of, it's changing people's ideas about where we could be looking for planets, and also just sort of it's caused so much excitement that I'm really really looking forward. We're still waiting for that that Earth-sized planet.
That Earth-like planet.
Earth-like planet in the habitable zone, and that still hasn't been discovered yet. So that'll be it. That'll be the big one, and that's just around the corner. I mean, those planets are sitting in Kepler's data right now, so I'm sure of it. And it was just a matter of someone teasing out the data and making that discovery.
But think about
let's move on.
Well,
go ahead.
I mean, even if we had a probe around Alpha Centauri BB, it would take a signal for it to get back to us, telling us what it saw that day, would take 4.5 years. So I mean, how do you logically have a mission like that? Even Voyager only takes a few minutes to send back information from the edge of the solar system. That's a year. Yeah. 4 years of data you gotta wait for.
But 4 years is
within
better
a thesis timeline.
Yeah. A thesis. Yeah, exactly.
It's within a thesis timeline.
Right.
Not
so
but
you'll post like a bunch of questions to the spacecraft, and then you'll start your doctoral thesis, and then 4 years later you'll receive that information back. So yeah, it's a long timeline. It requires a very patient scientist. All right, well, let's move on. So this time we're going to move over to Amy, and Amy, you've got a story about a flash from a black hole.
Yes, a flash from our black hole, actually, at the center of our galaxy. So the discovery, where it was found, and it was a bit of luck, just sort of catching it at the right moment, by NASA's Nuclear Spectroscopic Telescope Array, or NuSTAR, which measures high energy X-rays, which is pretty neat because we don't have anything else that has been able to capture that really short wavelength of light. So just a little bit of background on NuSTAR. It was launched on June 13th, so it hasn't been up super long, but it's already done some pretty awesome stuff. And because it's looking in these super high energy X-rays, it can see things like black holes and supernova explosions and particle jets traveling near the speed of light. So it's looking at some of the most extreme environments and galaxies in the universe that we can see. So it's got these two arrays of 133 mirrors each that bounce the X-rays back at each other and turn that into some kind of data. And it's also been playing nice with other observatories. It's teamed up with NASA's Chandra X-ray Observatory that sees low-energy X-rays, and the Keck Observatory in Hawaii, which looks at infrared, takes infrared images. All in all, to get a better picture of the black hole at the center of our galaxy, which is called Sagittarius A. So our black hole is a pretty mild-mannered black hole. It doesn't, it's not crazy evil or devouring fuel and stars that come near it. It kind of nibbles or just lets stars pass on by without doing anything to them. But it does, it does take in that fuel. And when it does take in fuel, it exhibits the same characters that all black holes do, which is a release of excess energy. So that's what NuSTAR saw, is the X-rays emitted by the black hole as it consumed energy. The matter that was shot out, it measured at 180 million degrees Fahrenheit, and it originated from an area where particles travel quite close to the speed of light. So this is pretty neat. It's kind of not something you see every day. So we kind of got lucky to actually see this, and it's helping astronomers who know how to interpret this data figure out how black holes actually consume fuel and grow, like the physics of how that actually works. So it's pretty neat to sort of have that insight into what is right at the center of our galaxy.
And this is one of the major discoveries. Oh, cool. Jason's got a picture here. This is one of the major discoveries of our sort of modern age of astronomy. You know, astronomers have known a long time about these quasars, right? These super, super bright point-like, star-like objects that are actually billions of light years away. And it turns out, you know, a long time it was a mystery, and it turns out now that really a quasar is just a supermassive black hole that's feeding. So at a certain point, you know, black holes will consume stars, massive amounts of gas and dust, and then they go into this sort of bright phase where they shoot out all this energy, and then they have these other times when they're quiet, and then it's just a regular supermassive black hole. And so most of the time what we have here in the Milky Way is this regular supermassive black hole, but it's not always quiet, it's sometimes feeding. And so the amount of material that it's actually consuming, you know, it can... Because it gives us so much radiation, astronomers can detect fairly minor little, I guess, outbursts. And so this is one of these little minor outbursts. There's bigger ones I know predicted to happen in the future, right?
Now, is this from the same cloud of gas that's heading towards Sagittarius A star and is supposed to be gobbled up within the next year or so? I mean, they spotted that over at ESO and announced it, I think, earlier this year, that there is a cloud of gas that's heading in towards that supermassive black hole, and I think they estimated it to be something about like 3 Earth masses. I don't know if this is it and it started to chomp on it, or I mean, just I haven't heard.
I don't know actually. The press release that I sort of found for this article didn't mention anything about a 3 Earth mass cloud of dust. Maybe it is, but I'm not sure.
I think that's a
vaguely
separate
remember
thing.
hearing about that.
Yeah, I think it's different.
Yeah.
That seems that like it would be traveling really, really fast if they just saw it near a star and now it's already being devoured. I don't know. I don't have a good sense of scale of these things. This is way too big.
Well, I think if that's not it, then that will happen. I believe really soon. And within the next, maybe starting up in the next few months or so.
And of course, because the supermassive black hole is 30,000 light years away, it's actually already happened.
It's already happened. It's done. It's over with.
It's an old news. Yeah. All right. Well, let's move on. So
in astronomy.
That's what we do. Yeah, it's true. Yeah, we only talk about old news, stuff that are billions of light years old. Okay, so let's move on. We're going to talk to Nicole now about a massive, 2 million light year long afterburner coming out of a galaxy. Like I said, this really is the black hole show.
It's Black Hole Week! Yay! Yeah,
like Shark Week.
Yeah, like Shark Week, only it will devour you even more.
And your whole planet.
Horribly.
Yeah.
So this is another one of these supermassive black holes, like Fraser was talking about, these quasars that they're really bright. This supermassive black hole that is actively feeding on material in the center of a galaxy. So this one has the lovely name of PKS 0637-752. This means that it was studied by the Parkes telescope. It's in the southern hemisphere. I don't know if you guys have the picture, can get the picture up from the press release, but they're studying this long jet from the supermassive black hole. Not all of the material that's coming down on the supermassive black hole necessarily gets eaten up. Some of it gets pushed away, and that's when we see flares like what Amy was talking about. And with these actively feeding black holes, these quasars, you get a jet of material that you can see with a radio telescope. This one can actually be seen with a radio telescope and an X-ray telescope. So it's X-ray bright, which is unusual for this type of source, and it's radio bright. And so, does anyone have the picture to show, or should I screen share it?
We're racing to find the picture.
Okay.
Find it. Is there a link?
I have the link in the chat.
Oh, there it is. Okay.
Yeah. So it's got these dots, these diamonds that are reminiscent. That are reminiscent of. There we go. That are reminiscent of shock diamonds in a jet afterburner from a jet airplane. And so that's why people have been comparing it to that. Although in the paper, the astronomers are not sure if it's being made by the same mechanism. So there's 2 ways that this could be made. Either these diamonds can be made because there's a jet of material that's going through a shock, and there's a regularly spaced shock. And that's what usually happens at the back of a plane. However, that seems unlikely because then over this entire megaparsec or million light year long jet, you have to have the same density of the surrounding material, and that's unlikely. So it's also possible that they actually call it a jet nozzle. The jet nozzle of the black hole is spewing forth matter at regular intervals. And so this is something that it would have to be doing it over several 1,000 to 100,000 year time scale. It would actually be spitting out these globs. It would be so that's because the accretion disk, all the matter that's trying to squish its way into the black hole, something's unstable, and so it's actually coming out periodically. And we've seen evidence of this before. I used to work on really, really tiny versions of these jets, and they had evidence that there were periods of on and off and on and off over several thousand years. Another possibility for this one is that it's actually a binary black hole. And so a binary black hole, that would be stirring up the accretion disk and making it come out in these globs, in these blobs in a periodic way. So just from this image set that they took with the Australia Telescope Compact Array, they're not sure which scenario is the most likely. All three are still on the table. So they're going to be following up with more detailed measurements and higher angular resolution, so there'll be even prettier pictures and polarized pictures of this coming out soon. But it's weird black hole physics, and like Fraser said, we've known about these for decades, and we still don't quite understand the mechanism by which these are made. And so that's still a big mystery in high-energy astrophysics.
I actually recently did an article on shock diamonds, so it's kind of partly in my brain, and it's a really interesting physics, the way the sort of waves of gas compress and sort of bunch up and ignite and stuff, and so it's interesting just to kind of imagine some kind of natural rocket valve, being created by the magnetic field around a supermassive black hole. I mean, we see these jets, we know they have these incredible magnetic interactions, and they're blasting out this jets of material, but if they're actually turning into these shock diamonds in the the exhaust of this supermassive black hole, that's amazing. That is, I never would have occurred to me that would even be possible. But now that I think about it, I'm like, oh yeah, I think I kind of understand what's going on there without having to do all the complicated math. So all right, so let's talk about, Jason, we're going to talk with you now about the fact that now a rocket has exploded into tiny little pieces, creating a shrieking hail of small bits of metal surrounding our planet, forever closing us off to space exploration.
That's true. We no more rocket launches where space is closed.
Wah, wah.
There's a little irony here. We're being a little sarcastic. Don't, cancel NASA just yet.
Well, as it turns out, there was the background to this was there was a Russian rocket launch back on August 6th, and it was supposed to put 2 communication satellites into orbit. Well, the Proton rocket launch went fine, but when it got to the Breeze M stage, the upper stage, one of the burns, I think the 5th of 6 burns canceled early. It only lasted about 7 seconds and then shut off. Now, typically that burn was supposed to last about 18 minutes. So that left about 10 to 15 tons of hydrogen fuel inside that upper stage. It left the rocket left the upper stage in too low of an orbit. The computers kept working. Eventually they spit out the satellites. They were in too low of an orbit. So that whole mission ended up being a failure. But the problem is now they had this upper stage that was just floating around up there. This has happened before. This is the 3rd time they had a failed, partially filled Breeze M, and they thought it was going to last maybe about a year or so. Well, it turns out that it lasted only about a couple months, because on October 16th, apparently the whole thing disintegrated, sending bits and pieces of Breeze M all over low Earth orbit. So the problem there is that not only do we have satellites in low Earth orbit, we have to pass through low Earth orbit to send anything up. The space station's also up there, and although right now the space station's in no immediate danger from the over 500 pieces of debris M upper stage that are floating around up there, it does supposedly pass through the debris cloud. So, you know, they're going to have to keep an eye out for that. And basically, you know, we just added a little bit more space junk to what's floating around Earth, and just, you know, just another bit of danger, and another reason to maybe figure out a way to go up there and clean up some of that stuff.
Yeah, this is this is one of those problems. You know, some people have been very catastrophic, sort of about this dilemma that, you know, you're going to get this cascade at some point, possibly, where these particles are crashing into each other. These bigger pieces of metal are smashing into other pieces of metal, and that's creating smaller and smaller debris until you get to the point where they just interact, and they can't track them. But I guess the chance of a collision just grows and grows as there's more and more objects. You can imagine if you have, like, you know, you have two spent rocket boosters and they're on different orbits, the chance of them actually colliding is fairly low. But you get to the point where you've got, you know, 1 million fragments of metal all interacting with each other. The collisions are going to happen more and more, and you might get to this point where it's just too dangerous to even try to leave Earth's orbit because there's all of these fragments of metal. So,
oh yeah, I mean, basically, you know, they're up there. I mean, all of those little bits and pieces are going 17,000 miles an hour. So,
yeah,
you know, it doesn't matter.
And they could be going in opposite directions, and so, yeah, no, they're, you know, any interaction will be an explosion and shrapnel. And,
yeah.
So, and the shrapnel hits the shrapnel.
It's been suggested already that that at various points in its orbital path, the space station will be passing through the debris cloud, possibly even for several days at a time. So that, you know, they're going to have to be really careful on how they spot and how they track these, you know, over 500 currently over 500 bits of the upper stage.
So do you know about how high it was when it exploded? I mean, I know the ISS is about 200 miles up, but was it lower than that? Is there sort of any way that some of it's going to fall back down?
I don't know. It's actually pretty variable. It's not at a single set height. And if you bear with,
sort of envisioning like a swirl of bees.
Yeah, I mean, they're just kind of, you know,
like a very cartoonish sort of.
They're just kind of all over the place, and yeah, the altitude, the fragments are at altitudes ranging from 250 kilometers to 5,000 kilometers. So, you know, that's really a big range, and because the upper stage was initially at that orbital path. So it's basically, you know, it blew up, it disintegrated, it exploded, and then all those bits and pieces are still following that same path.
Yeah, and at a certain point, you know, as these particles get smaller and as they become harder and harder to track, harder and harder to retrieve, and just more and more expensive, you can imagine, you know, if you're going to try and go and find a big spent booster and then deorbit it again, that's a feasible task. But if you're going to try and collect up the 10,000 fragments, shattered fragments of that rocket, not so easy to do. So yeah, this is an interesting challenge. It's going to be a bigger problem, and, you know, and some of the sort of most nervous say that this could be a sort of down the road a catastrophic problem for space exploration. That
right, and this is the third time it's happened, and there's another one still in orbit from a failed launch attempt in 2011 that hasn't disintegrated yet. So it's only a matter of time, perhaps, before that one goes too.
All right, well, back to our theme of black holes and supermassive black holes. Nancy, you've got a story about a teeny tiny supermassive black hole.
Right, yeah, this is kind of in the same vein as jumbo shrimp and completely ambiguous. So, yeah, astronomers found the smallest supermassive black hole that they've ever observed so far. And while it's kind of considered a shrimp as far as supermassive black holes go, it's actually, you know, pretty big. It's estimated to be about 200,000 times the size of our sun, or the mass of our sun, I should say. But however, some of the real biggies of supermassive black holes are on the order of hundreds of thousands to billions of solar masses. So it is small in the supermassive range anyway. But kind of the big surprise here was that this galaxy had a black hole at all. It doesn't have a bright central concentration or bulge of stars in the middle, and so it was thought that perhaps this is one of the galaxies that did not have a supermassive black hole at its center. But a team of astronomers that were using Chandra, they found a weak X-ray source at the center of the galaxy, and then they also looked with other observatories to see what was going on there. And they looked at different wavelengths, and they saw varying brightness at the other wavelengths as well, and that was sort of telling them that there was some action going on there, that they had, something was going on. There's material was being pulled in to the center, and they determined that it actually was a black hole there. So, and they were able to determine the size of it just by using the relationship between the mass of the black hole and the amount of X-rays and radio waves that it generated. So, this is, it is the lowest mass supermassive black hole that we've ever observed, and the team said that this is probably the real low end of the supermassive range. But as the team pointed out in their paper, there is a growing body of evidence that there are other galaxies like this. It's a late type galaxy on the Hubble classification range, and there are other ones out there that don't have the classical bulge of stars at the center. So perhaps the findings are that you don't really need to have this central bulge as a requirement to have a supermassive black hole. So anyway, this is the ultimate oxymoron, a small supermassive black hole.
But isn't the evidence seems to be pointing towards, and maybe this is a question for Nicole with her PhD, that all galaxies have supermassive black holes, that it really just is now a given that if you see a galaxy, it's not whether if they have supermassive black holes, it's just
it had the caveat of all galaxies with central bulges. And so, yeah, that was known that all galaxies with central bulges, and that came out of the Hubble Space Telescope, a lot of work with the Hubble Space Telescope, and it also leads to the question of which came first, the bulge or the black hole. But this is kind of new, these galaxies that don't have central bulges at all. It still fits the trend that you have tiny, tiny supermassive black holes with no bulge, but it's saying that you don't need a bulge there to have it. I know Amy Rhines is an astronomer in Charlottesville who I went to grad school with, and she discovered one of the first of these in a similar galaxy as well.
So is it going to go down that route then, that essentially even bulge, no bulge, every galaxy has a supermassive black hole?
I don't think you're going to find them in a lot of dwarf galaxies. I think they've looked, and either you're not going to find a black hole, or you're going to find an intermediate mass black hole, which is still, the jury's still out on whether those exist at all, or we're not going to see any. I think there are still going to be dwarf galaxies out there that don't have black holes.
Okay. Well, so then sort of one last story so far, and we'll see if we have more time, was, excuse me, you just worked on this today, Nancy, about your chance to scream in space.
Right. Well, earlier this year, the Surrey satellite company that's based in the UK had a competition for experiments to be included on a nanosatellite that they wanted to put together. And what they wanted to do was to test out the capabilities of a smartphone to control a satellite in space while the smartphone was in space. And so what they wanted to do was to have people develop an app that could do that. And one of 4 apps that was chosen was one that was developed by students at the University of Cambridge in the UK. And what it'll do will play recorded sounds, and it'll be broadcast kind of. And then it's also going to play the sound or record the sound as it plays it to determine if there's any way that the sound waves would be traveling through the vacuum of space. And with the iconic tagline from the movie Alien, the most perfect sound ever to try and play in space is someone screaming. And so what these students are doing are asking people to send in 10-second videos, 10-second minimum videos on YouTube of them screaming. And then there's going to be a competition where I think it's the top 10 screaming videos will be loaded onto this Android. It's an Android, not an iPhone. And yes, right, yay, go Android. And
here on Google Plus, we love Android.
Yes.
Thank you, Google, for allowing us to continue doing this show on your network. Go Android.
No, I think that there have been several cases where people have sent iPhones on like high altitude balloons, which go up into the stratosphere, and then there's also iPhones that are on the International Space Station. But I think this is the first launch of a smartphone incorporated into a satellite, and so they're actually touting it as the world's first smartphone nano satellite. So, and just kind of an interesting tidbit that I found out as I was researching this story, I was trying to find out who or what launch vehicle is launching this nanosatellite, and Surrey is not disclosing yet who is launching it, but it's supposed to launch before the end of the year. So either they haven't nailed it down yet, or it's something big. So anyway, that's just kind of interesting. But yeah, so we should post the link to this I think it's screaminspace.org or something.
Oh.
Anyway, I'll grab the link.
That's it.
They have a few, yeah, there we go. Yeah. But it's just, they said they don't expect to actually get any recording, but it's just more of a fun thing of people to do, to send in their screams.
That is really cool.
And there are three other winning apps too, so that are going along with that.
Well, that's awesome. And then I think there's one last piece of news, and I guess this is back in your camp as well, Nancy, which is that the recent Soyuz just docked with the space station.
Yep, just this morning, the Soyuz, it just launched on Tuesday, it arrived with 3 astronauts and 32 fish. So that's kind of exciting. They have in the Kibo laboratory, there's a new aquatic habitat that was brought up on one of the recent Progress ships. And anyway, so we'll have a chance to see fish swimming around in space, and just I think it's going to be interesting to see how they try to adapt in space, and that's basically what they're doing, is looking at how the fish will react to microgravity, and also if there's any radiation, they'll be testing the radiation levels and seeing how the fish react to that as well.
Cool. All right. Well, I think we're trying to go with a new sort of shorter, quicker format for the Weekly Space Hangout, so I think we've cranked through a whole pile of news and given everyone some context for their week, so I think we will let everyone go. Before we do, though, I think we need to know where we can find more of everybody. Amy, where do we find more Amy?
AmyShiraTeitel.com is where all my stuff is based. You can find me on Google Plus and Facebook and Twitter, AST Vintage Space. Yeah.
Okay, cool. Nancy, obviously, you can find us at universetoday.com.
Yep, Universetoday at Nancy_A on Twitter.
Perfect. Nicole Gugliucci?
noisyastronomer.com and on the Twitters and everything else. And I live over at CosmoQuest.
That's right. And is there something people can analyze at CosmoQuest today?
Yeah, we have reached 1 million craters between the Moon and Vesta. So we actually have some really cool science results coming out with the Moon, but we've still only mapped part of the surface. So come help us map the Moon and Vesta.
Jason?
I blog at lightsinthedark.com, Universe Today, and I'm on Twitter at JPMajor.
Awesome. All right. Well, thanks everybody for joining me this week to run through the space news. Thanks for everybody watching. Really appreciate it. Next up, we're going to be having our virtual star party on Sunday night when it gets dark on the West Coast. We're going to have a bright, stupid moon, but apart from that, it should be really good. Jupiter will be out, so it'll be nice. Moon! All right. We'll see you all later. Thanks a lot.
Bye!